You know that feeling, right? That one infuriating bug you've spent all afternoon hunting? The one that has you seriously questioning your life choices. Well, what if I told you there's a way to cut that debugging time in half?
And no, that is not an exaggeration. We're talking about a potential 50% reduction in debugging time. Research actually shows that using the right AI prompting techniques can slash it by that much, sometimes even more. So how do we do it? Let's dive in.
Okay, so here's the secret. It isn't some magical AI that just, reads your mind. The real power is in how you ask. It all comes down to a structured approach that gives the AI exactly what it needs to solve your problem, and solve it fast.
But first, to really get why this solution is so powerful, we have to appreciate the size of the problem we're up against. Because let's be real, debugging isn't just a small part of a developer's job, it is a massive time sink.
And look, the numbers do not lie. Industry studies show that developers spend a staggering 25 to 30% of their coding time just hunting down and fixing bugs. Think about that for a second. That's almost a third of your entire week spent just on fixing things instead of building cool new stuff.
And you know what? A lot of that time is wasted because of this super common approach. We've all done it. You just paste some code into an AI and type, "fix this." And what do you get back? Usually a generic guess, maybe a solution that totally misses the root cause, or sometimes something that's just plain wrong. The AI is essentially flying blind.
All right, so let's stop flying blind. It's time to switch gears to a more deliberate, a more systematic method, one that turns the AI from a simple guessing machine into a precision diagnostic tool. And we call this systematic debugging prompting. It's basically a structured way of asking for help that gives the AI the whole picture. The code, the error, what you thought was going to happen, and it directs it to find the real problem, not just put a Band-Aid on the symptoms.
Here's a great way to think about it. Imagine going to a doctor. You wouldn't just walk in and say, "I feel bad," right? Of course not. You'd give them context. You describe your specific symptoms, when they started, what you were doing. The exact same principle applies here. More context equals a more accurate diagnosis. Simple as that.
So this whole approach really breaks down into 5 key pillars. First, you've got to provide the full context. Second, include those test cases, what you expected versus what actually happened. Third, ask really specific targeted questions. Fourth, and this is crucial, push the AI to find the root cause. And finally, number 5, always ask for an explanation. That's how you actually learn from it.
Okay, enough with the theory. Let's see this thing in action with a real-world before and after example. And trust me, the difference is pretty dramatic.
So here it is, the classic bad prompt. And hey, no judgment, we've all done it. Just fix this code, and then you dump in a function. But the AI has absolutely no idea what fixed even means in this context. Should it handle discounts? Should it add error checking? Refactor for style? It's just taking a complete shot in the dark. Okay, now let's build a much better prompt step by step. We're going to start with the absolute basics. Identify the language and provide the code. This is our foundation, simple but essential. Next up, we add what is arguably the most critical piece of information, the behavior. What did you expect to happen and what actually happened? This simple expected versus actual format, it instantly tells the AI exactly what the failure looks like. It's a game changer. And finally, we supercharge the prompt with specific questions. See, we're not just asking for a fix anymore. We're asking why it's broken, how to fix it properly, and for an explanation. This is what transforms a simple request into a really powerful diagnostic and, just as importantly, a learning tool.
So you've seen the difference this can make, right? Now let's package all of this up into a simple, actionable playbook that you can start using on, your very next bug.
All right, here's your go-to template. Maybe even screenshot this. Start with the relevant code. Describe that expected versus actual behavior. If there's an error message, include the exact one. It's also super helpful to list what you've already tried. And then, always remember to ask, why is this happening, before you ask, how do I fix it? Always request a fix and an explanation.
Okay, now for a little pro tip, because not all AI models are created equal. Based on a ton of testing, we're seeing some pretty clear patterns emerge. GPT-4, for instance, tends to be a beast at complex logic bugs. Claude is fantastic for improving code quality and maintainability. And Gemini, it often shines when you're dealing with those really tricky runtime errors.
So, let's break that down even simpler. If you've got a complex algorithm, reach for GPT-4. If you want a clean, maintainable fix with a really clear explanation, give Claude a try. And for those frustrating concurrency or environment issues, Gemini is a great choice. Seriously, using the right tool for the job can make a huge difference.
Ultimately, look, mastering systematic debugging isn't just about fixing bugs faster. It's about reclaiming your time. And that's time you can spend on new features, on learning new technologies, or, hey, maybe just logging off a bit earlier for once. So the real question is, what will you build with all those hours you get back?